Hello, my name is Alan Pickering and I'm trying to give you a demonstration of this latest project of mine, low temperature differential Stirling engine. I've always fancied one of these but never got round to doing it. I've been building steam engines for the last 50 years. And this is the smallest thing I've ever done. I decided that this wasn't particularly a model engineering exercise and the ones that you see are not very nicely made, in as much that the conrods are loose and floppy and they don't have any bearings. I've later found out that in fact it's a good idea. I wanted to make one with bearings, like this, if it can be shown, and like this. I only think it's 532 bearings, little ball races. The problem is, you've got stiff little connecting rods and they've got to be totally lined up with with the pistons, and this is almost impossible. But if you have floppy bits of wire in big holes wobbling about, they automatically line themselves up. But it's not model engineering, and so I don't like that very much. I bought this off eBay because I couldn't get hold of all the bits to make one. It didn't work too well, and so I decided to try and make it a bit more model engineering like. So I stripped it down, and these are the bits that I removed. The column, all the 12 screws holding it together, and the two bearings for the displacer rod and the conrod. Also a perspex top, which is quite thick. This is not a good idea because, for one thing, the holes were drilled here right next to the power cylinder, which weakens the plastic. Messing about with it, I finished it and put it together, and I just decided to put it on some hot water. When I put it on the hot water, the perspex just started to crack, and it just cracked all over, as you can see, and well, that was the end of that. So I had to make a new top. So I made it out of steel, and I put a big magnet on the back of it, which is in fact a heat sink. There it is. And it makes a big difference. It's a bit difficult holding these cameras still. It'll run for 20 minutes, and I'll put the camera down and get a drop of hot water on the go, and even put my watch here so you can get an idea how long it's running for. There we go. Just get some hot water. Okay, there we go. Give us a little tiny stroke. Let's see if I'm thinking about it. There she goes, nearly. It's amazing how slowly these things will run. The two weights on the spokes are little bits of lead. In fact, it's solder, plumber's solder, crimped on. What happens, it's not a case as much as balancing, it's the fact that it's a single cylinder engine and it only has one power stroke. And when the piston is at bottom dead centre, it's starting its power stroke. So it pushes up quickly, and then the flywheel takes it round to the bottom again. Now, these weights are more or less to compensate for the power stroke, trying to give it a little bit more evenness. At present, it's not very even, but given enough time, it starts to go quite quickly, and it evens itself out. It'll run for about 20 minutes like this, and it'll keep going a bit faster until the water cools down. It's a bit difficult holding this lot still here, especially with one hand. But ever so awkward to make. I put in tiny ball races in the big end and the displacer big end, if you like. In retrospect, this is a bad move. Although it looks nice engineering wise and it pleases me no end. If you want it to run on the heat of your hand, then you want a floppy bit of wire in there in a big hole so that the whole caboodle lines itself up as it runs. And although it's wobbling about and doesn't look very nice, it does run better. But being a model engineer, I'll try and make it quite as good as I can as a model engineer in exercise. This lump of steel is in fact a magnet which is acting as a heat sink, and it makes quite a big difference. In order to not have too much angularity on the connecting rods, there's a little bit of pipe, a bit of polyurethane pipe in there, about an inch of it, and that takes up some of the angularity out of it, because these things have got no power. Now, when you make these connecting rods, you've got to bend them exactly 90 degrees. It's no use doing it by eye. You've got to get it dead right. If they're 91 degrees, they don't work, because you're putting angularity on the piston, which is glass in this case, a glass cylinder and an aluminium piston. Now, if you don't get this angle at 90 degrees going through the bearings, what happens is the rod twists, and when you look down at the displacer, which is a polyurethane invention, it rotates. It would go left and right, and it looks awful. So it's very critical to get this rod dead square. Now I've used a fairly big rod. It's a bit of stainless steel, but if you want it to run very well, use the thinnest stuff that you can, because then you can get it lined up more accurately. I mean, you're talking tenths of a thou to get this lot dead right, and making it is one thing, getting it to run is another thing. I'm very pleased with this little engine. All the bits and pieces that I took off the original engine, I put them down here. One's the column, one's the perspex plate, and all the others are the brass big end bearings and spacers and nuts and bolts. 20 should be 24 nuts and bolts holding the plate on. Really, these nuts and bolts should be made of polythene. 6BA polythene bolts about an inch long. When you go on eBay, they want £1 each for them. So I thought, no thank you. It's starting to slow up a bit now. It gradually slows up and then it picks up speed again for some unknown reason. This will probably be my last model engineering project. I'll put a link on to my other hot air engines that I built, about another half a dozen of them, big ones, proper engineering jobs, and I'll put a link there on the YouTube. I take them round shows, and they're very, very heavy. In fact, they're too heavy for me to lift. They're about 75 to 100 pound in weight. I like hot air engines because in the past I've done nothing but build traction engines and locos and steam engines. They all require a boiler, and getting it tested, they want the lagging off, all sorts of things, and being a boiler tester myself, I can't test my own boilers, so this has always been a big contention by me. I can recommend this book. It's quite expensive on eBay, if I can hold the camera still. It's a good read. It's starting to speed up again now for no reason at all. I would expect this to go on for another 5 or 10 minutes. I can't keep the camera very still, I'm afraid. you can see that the thing is running fairly smoothly now. These little balance weights, they made a big difference to it, as did the heatsink. When it gradually cools down and wants to stop, it never actually stops. It just barely turns round, but it still seems to have one last gasp before it finally stops. But I don't think this camera will keep going long enough to see it start to peter out. It's totally amazing how these things work, how they work at all. Now, I replaced the column because there's a bad design in this thing. One was the column, you couldn't take the piston out of the cylinder because it hit the flywheel. So I made a column out of stainless steel and shaped it so that the flywheel missed the cylinder, and I could get the piston out without pulling the machine to pieces. The same applies to the displacer side. I didn't want the conrods to have a bend or a kink in them, so I had to shape the upright pillar in order to get a fairly straightforward conrod action. And this I have achieved up to a point. I don't think this will be any more engines from me. I'm 84 now, and I've had enough of model engineering. My workshop, although it's magnificent, is basically a museum piece. And if you look at my other hot air engines on YouTube and you watch till the end, I'll go around the workshop and explain everything, to what the bits and pieces do, the lathes and mills and things, surface grinders, but not this one. I'm just doing this in the kitchen just for the hell of it. In fact, I only finished it today. How's the time going? I think it's been going for about a quarter of an hour at present. It's hell trying to keep these cameras still. I would imagine it would stop at about 20 past 12. No, not 12. I can't tell the time now, I've got the watch upside down. See, it starts to go slowly when it starts cooling down. Then for some reason or other it just picks up again and it tends to increase in speed before it finally starts to go slowly. If you wanted this to run dead smoothly, I think you would need 2 cylinders. It's starting to slow down, but in practice it'll keep going for another few minutes. So I hope you like this little video, and also have a look at my other hot air engine videos on YouTube. Just type my name in, Alan Pickering Hot Air Engines, and there'll be at least half a dozen on there. Different shows or testing in the workshop. So I'll just let this one go, and so that's hope you enjoyed this. This is Alan Pickering signing off. It's amazing, it just keeps on going right to the last breath. Bit like me, really. There we go. At least I've got it still now. This shows that it must be reasonably well balanced. There we go. Right, it's given up the ghost. Thank you for watching.